Hello 12th standard students, welcome back to chapter 2 complex numbers. Today we are going to see the concept of conjugate of a complex number. What is conjugate of a complex number? Given x plus iy is defined as the complex number x minus iy. So what they have done is they have changed the sign for the imaginary part of the complex number. Okay, wherever you get I, the sign before that I term should be changed. If it is plus, it will become minus, and if it is minus, it will become plus. So here x plus iy has become as x minus iy. Okay, and the product of the complex number with its conjugate, when you multiply one complex number with its conjugate, you will get a real number. How is it possible? Because here this is a plus b and this is a minus b. So what is the formula for a plus b into a minus b? You get it as a square minus b square. Similarly here for you a is x and b is your iy. So a square x the whole square minus iy the whole square. So when you square, this I square will give you a minus 1. So this minus into this minus will become as plus. So you will get it as x square plus y square, which is a real number. Okay, so this is how you get the real number. Now geometrical representation they have given x plus iy. Always we take for the x plus iy this in the real axis and this as the imaginary axis, because this comes at the second. So minus 2 x in the x line and y. So I have given an example here. Minus 2 plus 3i is a complex number. Okay, this is z. Now how will you plot this on this one? Minus 2 is here and 3 is here, so you will plot it here. Okay, you can plot this point here. Minus 2 plus 3i. So what is the conjugate for this? Conjugate you represent with the bar. So minus 2 minus 3i, because you are going to change the sign before the I term. Okay, not for the real part, only for the imaginary part. So minus 2 minus 3 will come here, isn't it? This is minus 2 and this is minus 3. So you can plot the point here. So this is going to be minus 2 minus 3i. So again you can join these two with the origin. Similarly here also from here to the origin. So this is the geometrical representation of the complex numbers. Okay, so they have given in the general form. I have explained you with the real number system. Okay, minus 2 plus 3i. And properties of complex number, you are going to just know what are they, and when we go into the problems we will use this. I'll give you examples for 2 alone, which is given and explained in the book. Z1 plus Z2 the whole conjugate give you Z1 conjugate plus Z2 conjugate, or you can read it as Z1 bar plus Z2 bar also. Similarly subtraction also same, you can separate it one into another. Excuse me. For multiplication also it is the same. Z1 Z2 the whole bar equal to Z1 bar into Z2 bar. So you are going to prove these 2 properties only. The remaining is going to be the same. Okay, division also the same thing. The whole bar when you take, you can separate it to the numerator as well as the denominator. One condition, with one condition, Z2 not equal to 0. And real part of the Z is going to be Z plus Z bar by 2, and imaginary part is going to be Z minus Z bar by 2i, because you will get I for imaginary, so 2i. And Zn the whole bar is going to give you Z bar the whole power. That is indices. Okay, complex number always obeys the indices law. So according to the indices you can separate them. And if Z is a real, if and only if Z equal to Z conjugate. So when Z is equal to Z conjugate, you get Z as a real part. So you will not have an imaginary part there. And Z is purely imaginary when Z equal to minus Z bar. Purely imaginary means the real part will be 0 and you will get only the I part. Okay, and the 10th property is Z, when you double conjugate it, you get the answer as Z. That is obvious. Okay, now we will go into this addition property. We are going to prove this one. For that I am going to take two complex numbers. Let Z1 be x plus iy. Okay, and you name it as x1 y1, and Z2 as x2 plus iy2. Now what is our property? Z1 plus Z2 the whole conjugate. So first you write the z1 x1 plus iy1 plus x2 plus iy2 conjugate. Okay. Now for this, what you are going to do within the conjugate itself, you are going to separate the real part and the imaginary part. So x1 plus x2 gives our real part, and I into y1 plus y2 gives our imaginary part, and you write the conjugate there. Okay. And then now actually why do I separate the real and imaginary part? Because when you are going to write the conjugate for this, you are going to change the sign for the imaginary part alone. So when you combine both the imaginary parts here and here only, you will get it as in the standard form of a complex number. Okay. So when you take the conjugate for this, you will get it as x1 plus x2. This plus will become as minus I into y1 plus y2. Now you can separate this into two, x1 minus iy1 plus x2 minus iy2. So this is nothing but equal to z1 conjugate plus z2 conjugate, which is equal to our RHS given in the question. Okay. So we have proved this. Similarly, you are going to prove for multiplication, and this can be generalized. You can take it for any number of complex numbers. When you take the whole conjugate, it can be separated into separately as conjugates. Okay. Now we shall go into our multiplication. Same rule we are going to use for multiplication also. So let z1 equal to x1 plus iy1 and z2 equal to x2 plus iy2. Now here you are going to multiply z1, z2, isn't it? What is our z1, z2? LHS is going to be whole conjugate. So z1 is x1 plus iy1 into x2 plus iy2, the whole conjugate. Okay. Now when you multiply two complex number, we follow this rule. Do you remember this rule? We have already done. So real part into real part will come first. So applying this rule, you are going to get it as x1, x2 and the imaginary parts together. So I square you will get, so minus y1, y2. How do you get this? I square into y1, y2. This I square is going to give you this minus. Okay. This is how we get this minus y1, y2. Now you combine both the real into imaginary, you will get x1, y2. Similarly, I into y1, x2. And for the whole thing, you are going to apply the conjugate. Okay, this line you have to put. Okay, then now you can take the real part separately, and these two constitute the real part and these two constitute the imaginary part. You can take out this I. Okay, so this is going to be like this. Okay, when I put the I outside, you are going to get it as x1 y2 plus x2 y1. Okay, now you can apply this conjugate. Sorry, conjugate has gone here out. Okay, so when you take conjugate for this, you are going to get it as x1 x2 minus y1 y2. There is no change in the real part. Here this plus alone is going to become as minus I into x1 y2 plus y1 x2. Okay, now you can separate the real part and the imaginary part. So what are you going to get now? So this is nothing but going to give you, so let we name it as 1. Okay, now we will do the RHS separately. What is our RHS? Z1 bar, Z2 bar. So what are you going to get? X1 minus I y1 into x2 minus I y2. Using the same property, real into real. So you will get it as x1 x2 minus y1 y2 and then minus I into, because here minus I is common on both the terms. Okay, so minus I you take it outside, you are going to get the same x1 y2 plus y1 x2. This is going to be our second part. So from 1 and 2, from 1 and 2 we get LHS equal to RHS. Therefore, Z1 Z2 the whole bar equal to Z1 bar into Z2 bar is proved. Okay. So similarly we can prove the other properties also, but these two properties are very important. So I have given you the proof with the general complex numbers. Okay. Thank you.